The HTV held very closely by the robotic arm and provides a nice workspace for them to grab the new batteries, install them onto the actual truss segment, the part of the station, and take some of the old batteries over. There's a complicated series of maneuvers as that pallet only can fit 9 batteries. There's 12 total old nickel-hydrogen batteries that need to be disposed of, so some of them will go back to that external pallet, and some of them will be stored on the adapter plates that connect the lithium-ion batteries adjacent to them as a permanent storage base. Now again, those batteries, you can see the lithium-ion there in blue, the same dimensions, same shape as the nickel-hydrogen, just makes the process of switching them out a little bit easier. They essentially look the same, but they're just a little bit heavier as they contain the lithium-ion technology. Now the adapter plate will be installed adjacent to the lithium-ion batteries with a connector to route that power. Now again, some of the nickel-hydrogen batteries will be put back on the external pallet, and the external pallet will be released from the station by HTV and burned up in the atmosphere, but some of them will be stored on top of the adapter plates as a place to store them, those that cannot fit on the external pallet. The two spacewalkers continuing to get set up. Again, Andrew Morgan on the right. He'll be wearing the suit with the red stripes. Extravehicular crew member number 1 today on the left. Christina Cook of NASA wearing the suit with no stripes. They have a short list of the procedures on their wrist. You can see some of the orange tape that surrounds them. Now those procedures, there's a complicated series of maneuvers, including, you'll hear a lot, translation. That'll be one of the main things that they'll do. Just recently, the crew members completed some in-suit light exercise to purge some of the nitrogen from their body as they're breathing 100% oxygen through the power of the suit, the battery pack that's in the back. Now Andrew Morgan already being outfitted with, you can see in the hands of Luca Parmitano, this will be the safer unit. It attaches to the very bottom of the backpack portion of the spacesuit. The arms will fold out and will provide, in the case of an emergency, if in the unlikely event that a crew member were to become untethered during the spacewalk. Spacewalks generally from start to finish are spacewalkers are constantly tethered while at least outside the airlock. But in the unlikely event that they were to become untethered, this safer unit provides some propulsion to actually act as a jetpack and get them back safely towards the station. The techniques for using the safer are trained on the ground using virtual reality, providing many different scenarios and positions and orienting and training the astronauts to safely propel themselves back to the station in the event of an emergency. Luca Parmitano on the left, Jessica Meir on the right, inspecting and getting ready to install that safer unit onto the back of extravehicular crew member number 1 today, NASA astronaut Andrew Morgan. Now the safer unit is one of the last pieces of hardware to be installed and checked onto the spacewalkers before they are put into the crew lock that's behind them. You can see it's a little bit smaller of a volume, so they'll have to face opposite directions when the astronauts are put into the crew lock. Very strategically, but once they install that safer unit, Andrew Morgan will make his way with the help of Luca Parmitano and Jessica Meir into the crew lock and get him in a good position and out of the way so that Christina Cook can be next for installing those that safer backpack onto the rear of the spacewalking astronaut. Once those safer units are installed, the hatches between the equipment lock and the crew lock will be closed, and we'll start hearing some communication from the equipment lock side. NASA astronaut Jessica Meir will take them through the depressurization procedures as well as the Capcom here on the ground, then handing over to the ground IV, who will be the primary communicator from here in Mission Control Houston to the two spacewalking astronauts. That'll be astronaut Stephanie Wilson. Now there's a complicated series of procedures that'll take over this 6.5 hours. The crew members still getting outfitted to go into the crew lock for egress, and it'll be happening after depressurization. They'll exit the hatch. Now the main work they'll be doing is, again, upgrading some of the batteries on the International Space Station. You can see here sort of a 2D graphic of what we'll be actually working on today. To the left is the external pallet that's currently in position, held by the station's robotic arm, with 9 batteries, or 9 slots at least, on the outside. Previously contained 6 lithium-ion batteries, 2 of which have already been installed onto the International Space Station just 5 days ago on October 6th, when Andrew Morgan and Christina Cook already configured and got a little bit ahead of schedule with configuring some of those lithium-ion batteries. Now, the first set of procedures will be to set up the station, which you can see on the right here, the integrated electronics assembly on the right, with the adapter plate. The adapter plate, again, goes adjacent to those lithium-ion batteries that you can see in green, adapter plates in yellow. The old nickel-hydrogen battery from that slot 4 will be brought over to slot B. Opening up that slot 4, we'll be able to move battery 6, that's an old nickel-hydrogen battery, over on top of the adapter plate. Again, a nice storage area for that, and opens up a slot for some of the next procedures. Opens up a slot for that lithium-ion battery to take its place over in slot 6. Again, those lithium-ion batteries held by the external pallet. Spacewalkers will move that lithium-ion battery over to the empty slot. 3 of the lithium-ion batteries will be on this 2B channel, so that will be the last in this series of 3 on this channel. The remainder of the spacewalks will be taking place on the opposite channel, on the far port truss, the 4B channel. Now, of course, those lithium-ion batteries need adapter plates, so the adapter plate from right underneath will move to slot number 5, and the old nickel-hydrogen battery that currently resides in slot number 5 will move over to the external pallet. Once they're done with those procedures, they'll just clean up the work site and make sure everything is configured on the 2B channel. Their final tasks include getting some of the work prepped for the 4B channel on the other side of the far port truss to put the remainder of the 3 lithium-ion batteries on that side. If they get a little bit ahead of schedule, there are get-ahead tasks that they can complete that are both at the Port 6 truss worksite as well as the Port 4 truss, just a little bit inwards. On the way back, they'll be able to complete some get-aheads. That's if they get ahead of time. Now again, on the first spacewalk just 5 days ago, they did get a little bit ahead of schedule and actually got some of the work done that was supposed to be originally be part of this spacewalk today, October 11th. So this task list is a little bit new, and here is the exact rundown of what you just saw. Of course, exiting the International Space Station will be number 1, then prepping the work site, then the series of battery switches that you see there before cleanup, and getting ready to prep that next power channel. Some of the get-ahead tasks you see at the very bottom are just sort of nice-to-haves in this case, but are still very critical to the long-term maintenance of the International Space Station, and those will be located relatively close on the Port 6 truss and on the Port 4 truss. They'll be able to see what they can get and after they assess the timeline as they go through it. But again, Drew Morgan and Christina Cook, pretty fresh in their spacewalking experience at this point. Again, just completing a series, the first of the series of battery AVAs just 5 days ago. Both have their spacewalking legs nice and fresh. You can see Andrew Morgan already has the safer unit attached to him and has been pushed into the crew lock. Now you see positioned here in the center of the equipment lock Christina Cook, still aided by Luca Parmitano that you see to the left, European Space Agency astronaut, and NASA astronaut Jessica Meir to the right, installing that simplified aid for EVA rescue. Again, that is sort of a jetpack that's installed on the bottom portion of their spacesuit, just under some of the critical life support and sort of the life engine that's at the back of the spacesuit. Again, in the unlikely event that the spacewalkers were to become untethered during today's spacewalk, that simplified aid for EVA rescue would get them back to the International Space Station safely. Again, installing that safer unit is one of the last steps before they get pushed into the crew lock. You can see Andrew Morgan already in there. They'll have to face opposite directions to actually fit into that small space right before the hatches are closed, and they begin some of the next procedures to check and verify that everything is okay before they start depressurizing. Now, the official start time of today's spacewalk will begin once the astronauts switch to battery power, and we'll mark that time for you. That'll take place after depressurization. Now, while they're getting situated and get pushed into the crew lock to begin today's spacewalk, you can see that final push taking place just now. Jessica Meir and Luca Parmitano pushing them right into place. We'll be taking Ask NASA questions. Please keep sending them in. We do have one already about how the lithium-ion batteries got to the International Space Station. They were carried up on the H2 transfer vehicle. This is a Japanese Japanese cargo vehicle that lifted off from the Tanegashima Space Center just last month. Made a 4-day rendezvous to the International Space Station, was captured by the station's robotic arm. It currently is positioned on the the Earth-facing side of the forward end of the International Space Station. Now, in the unpressurized portion of that vehicle was the entire pallet that we'll see during today's spacewalk. It was removed robotically and had a handover maneuver from the station's robotic arm over to the Japanese robotic arm, then back to the station's robotic arm to make its way all the way to the far end of the International Space Station where it currently resides. We'll continue to answer those Ask NASA questions. Please keep sending them in throughout today's EVA, which will be to install those batteries and complete this series of upgrades. The two spacewalking astronauts currently inside the crew lock. You can see facing opposite directions to make sure that they fit. There's a hatch that you can see sort of at the forward end of that crew lock towards the top of the screen. Once they get into position and make sure all their tools and they're in the right positions and they have the right configurations, are able to access the screens and controls to make sure they have control of the depressurization. They'll actually close the hatch between the equipment lock and the crew lock and begin those procedures. While they're continuing to get situated for egress or exiting the spacecraft later, of course depressurization before that, let's continue to take some Ask NASA questions. This one from Michael, who's asking how long this spacewalk will last. Now, typically spacewalks are timed around 6.5 hours, and there's a variety of reasons for this. First, the 6.5 hours is just spacewalking time. Of course, the astronauts are in the suits much longer prior to that, as you just saw, getting suited up. There's a lot of pre-breathing, and they do some nitrogen purging with in-suit light exercise. There's also a post-period where they have a debrief of some of the activities that they did. It's a very long day from start to finish. But also the suits themselves are on battery power and are on isolated portable life support systems that include carbon dioxide scrubbing and a limited supply of oxygen, and that's just to give a nice little margin between the functionality of the suit and the performance of the astronaut and the length of time that's needed. Now, these spacewalks are carefully choreographed and coordinated months, sometimes years ahead of time to make sure that the procedures from start to finish are well-timed, well-predicted. And, of course, these are a series of ongoing spacewalks, so a lot of good data for predicting how these spacewalks will go in terms of switching out those new lithium-ion batteries for some of the older nickel-hydrogen batteries. Keep sending in those questions using the hashtag AskNASA. Those two crew members you can see on the right with the feet sticking up is EV1, extravehicular crew member number 1, NASA astronaut Andrew Morgan, assisted by Jessica Meir, who's getting in between the two astronauts, just getting ready to configure that crew lock space before they close the hatch and start the depressurization. On the left, EV2, Christina Cook, NASA astronaut, 2 spacewalks under her belt. She'll be wearing the suit with no stripes today. Now, on top of the crew members' helmets are cameras that will be providing live streams from the point of view of each of the astronauts. Andrew Morgan, there'll be a little translucent letter at the bottom corner of the screen. Andrew Morgan will be taking helmet camera number 18 and Christina Cook number 11.
Station, we removed the middle canisters, and they are 4 and 17 for step 63.5.
Copy. Good numbers. Thanks, Luca.
Luca Parmitano and Jessica Meir in the equipment lock of the International Space Station's airlock. Behind them in the crew lock, Andrew Morgan and Christina Cook, our 2 spacewalkers for the jet today. They're going through some of the procedures to make sure that the crew is ready for depressurization. Jessica Meir, you can see in her hands the hatch that will be closed between the equipment lock and the crew lock. And she's closing that hatch now.
Look on 1, step 70 and 71 complete.
All right, Luca, thanks for that. 72.1 is complete. We're putting 72.2 and 72.3 in work. We'll call you back shortly.
Now again, Luca Parmitano and Jessica Meir working through the procedures in the equipment launch to get those two spacewalkers ready for their 6.5-hour run. In the meantime, keep sending in those questions using the hashtag AskNASA. We have one about the batteries. Again, the two spacewalkers will be working on upgrading some lithium-ion batteries of the station, but replacing those old nickel-hydrogen. So where will they go is the question from Lamia. Now, the old batteries, there are 12 old batteries, and the external pallet that carried up new lithium-ion batteries has enough space for 9. So what will happen is during these upcoming or total series of 5 spacewalks, this is the second in that series, they'll put at least 9 of those nickel-hydrogen batteries onto the external pallet. That external pallet will be put back into the HTV cargo vehicle, which currently is on the Earth-facing side of the forward end of the station. And then when it detaches from the International Space Station, it'll re-enter the Earth's atmosphere and burn up with the batteries inside. The remaining 3 batteries will be stowed on various parts on top of adapter plates on some of these components. You'll see them as part of the techniques during today's spacewalk to put some of those nickel-hydrogen batteries right on top of the adapter plates.
I got you loud and clear.
Loud and clear, Lucas.
Okay, Christina, you're going to check that the switch depress pump power is off.
Press pump power switch is off. OFS.
Check that the depress pump enable LED is on.
Depress pump enable LED is on. OS.
Airlock Houston on Space to Ground 1. You have a go in step 76.
Okay, Mark, thank you. We copy go for 76, moving to the depress cue card. Go, Drew and Christina.
Good. Hello, Goose.
Okay, for Christina on the UIA, switch depress pump power to on. Wait 10 seconds for startup. Copy. Depress pump power on. Christina, you can open the depress pump man isolation valve. Expect alert tone. Depress pump man ISO valve open. Copy. Monitor your seat pressure gauge remains less than 5.5. Copy.
You 2 copy. 81 copy.
Jessica Meir, you can hear from the inside of the equipment lock those voices you're hearing on the other side of the crew lock. That's where Christina Cook and Andrew Morgan reside. They're confirming their steps. Depressurization is currently underway.
Pressure 12.5. Copy 12.5.
Good readouts from the crew on the other side of the hatch in the crew lock as they undergo depressurization. The pressure of the International Space Station is at 14.7 psi, just about what the Earth is at sea level. Right now they're taking it incrementally down to 5 psi. They'll have a stop and check for any leaks before they continue down to vacuum.
And airlock pressure, 11.5. Base. Airlock pressure, 11. Copy. Copy. Airlock pressure, 10. 10. Point 5. Copy. Point 0. Copy 9. Reminder, when the crew lock is at 6.0, you can expect an alert tone.
Copy.
Copy. And that's 8.5. Copy.
Good readouts from the crew as the crew lock on the opposite side of the hatch is depressurized down to the next increment, which will be 5 psi, just to check for any leaks. Good readouts, though. Jessica Meir on the inside, right on the forward end of this camera view, walking them through those procedures. Christina Cook waving from the window at the center of the hatch there. Now less than 8 psi. Again, that the increment we're looking for is 5 psi when they'll put a hold on the depressurization and check for any leaks.
Airlock pressure, 7.5. Copy. Copy, 7. Copy. Pressure 5.9. Copy 5.9. And Christina, when the crew lock is at 5.0, you will close the depressed pump man isolation valve. Copy.
Very close to 5 psi at this point. We'll get confirmation from the crew once it's holding, and they'll go through a series of checks to make sure that everything is good before they proceed down to vacuum.
Pressure 5.3. Copy. I'm showing airlock pressure 4.7 once we switch back over, so I'll go ahead and take the man ISO valve closed. Copy, man ISO valve coming close. And it is closed. Copy, closed. For both of you, on your DCM, switch display status until leak check question mark is displayed, and along yes, follow instructions.
We want leak check.
3 copies. In work.
Jessica Meir offering the next steps as Christina Cook works through them with Drew Morgan on the other side of the hatch there. The crew lock on the opposite side of the hatch holding steady at 5 psi. This is that important marker to make sure that there are no leaks before they proceed down to vacuum. Once they're down to vacuum, they'll switch their suits to battery power. That'll be the official start of today's U.S. spacewalk. After that will be a series of steps to exit or egress the hatch and begin going over to their work site at the very far port side of the International Space Station. Will they be conducting all of their primary activities for installing new batteries on the outside of the International Space Station.
EV2 leak check complete. Copy, EV2 complete.
EV1 leak check complete, and O2 actuator EVA.
Copy complete, and EVA for oxygen actuator and oxygen actuator EVA for Christina. Okay, that's somewhere. And O2 actuator is EVA for EV2. Copy. Christina, depressed pump man isolation valve open. Expect alert tone. Copy. Press pump man iso valve open. Okay, and that end is flipped. You confirm that you are open? That's affirmative. We are open. Copy. I'm opening the emergency MPEV. Monitor your suit pressure gauge remains less than 5.5.
One copy.
Two copy.
A great leak check on the other side of that hatch. Christina Cook and Andrew Morgan providing good readouts. Now continuing that depressurization down from 5 psi down to vacuum. Jessica Meir on the inside of the equipment lock working the way through the procedures with the crew on the other side of the hatch.
Life pressure 4.0. Copy 4.
And a great readout from the crew. The depress nominally going down to vacuum. Jessica Meir again working with the crew on the way down. While it's going down to vacuum, let's take another couple hashtag Ask NASA questions. This one from Kapil. Do they need a specific timeline so they can work in the daylight?
The crew lock gets to 2.0, you will close the man isolation valve. Copy.
Spacewalks last for a scheduled 6.5 hours, the one last week just exceeding 7 hours. In that time, the crew will be outside the International Space Station the entire time, working in both day and nighttime. Within that span of time, they can see up to 4 sunrises and sunsets. Now they have technology as part of their extravehicular mobility unit to help them through those tasks. They have goldized visors that they can pull down from their shades to provide almost like sunshades during the daytime. And on the sides of their helmets are lights that they can use to illuminate their work site in the nighttime.
Copy 3.
Still working its way down to vacuum. We'll take one more question in the meantime. This one from Matthew. How long does it take to prepare for a spacewalk? Now, the entire day is quite a long day. For a few hours beforehand, they're seated in their suits. First, they go through a briefing before they get suited up and start their pre-breathing exercise. That's the suit itself providing a 100% oxygen environment, so they have to purge that nitrogen. That time is shortened just a little bit by conducting some in-suit light exercise to make sure that nitrogen is nice and purged. Then the spacewalk itself is 6.5 hours, and then there's a debrief at the end. Now, that's just for the spacewalkers themselves. In terms of planning and executing a spacewalk, there's large teams here on the ground that work with extravehicular activities, working with tools and procedures that can take months and sometimes years to put together a series of spacewalk and make sure that it's going to make the crew member safe and accomplish the mission.
Copy. You can close the defrost pump man isolation valve.
Defrost pump man isolation valve closed.
Copy. On the UIA, switch depress pump power to off. OFS.
Depress pump power is off.
Copy off. You can report your initial tether config for egress.
Copy that, Goose. And Houston's listening in. We'll begin with our load path, starting with the airlock E-ring extender. We have Christina's right waist tether large hook. The airlock E-ring extender, gate closed, slider lock, black on black, and that is going to her right E-ring extender, and her small hook is connected to it, gate closed, slider lock, black on black. Beginning on her left E-ring extender, I have a red hook, gate closed, slider lock, black on black, to Christina's red reel, which is an unlock. Yellow hook, large hook, is to my red reel, gate closed, slider lock, black on black. My red reel is in unlock. My red hook is to my right E-ring extender, closed, slider lock, black on black. Yellow hook of my red reel is to my mini workstation. The right weight tether is to my mini workstation, and I can trace that down to my right E-ring extender. The small hook is gate closed, slider lock, black on black. That then, I think, only leaves Christina's waist tether on the left side. Small hook is to her left E-ring extender, gate closed, slider lock, black on black. And her large hook is to her mini workstation.
That sounds like a good config to me. Houston, do you concur?
Houston concurs.
Okay, copy. On your DCM, when the crew lock DPDT is 0, you can expect an alert tone.
Copy.
Now what you were hearing was just Andrew Morgan from the other side of that hatch. He and astronaut Christina Cook giving a good readout of their tether configuration. This is what actually attaches them to the International Space Station, just making sure that's in a good configuration, everything looking good so far to continue forward with the procedures to exit the hatch. Again, one of the main things that I look forward to will be when the crew members switch to battery power. That'll mark the official start of today's spacewalk.
Drew, my DCM is no longer showing airlock pressure, so...
Okay, copy. I'll watch the gauge.
Copy.
Airlock Houston on Space to Ground 1. It is daylight outside.
That that, Mark. Thank you.
Airlock pressure 1.1.
Mark, what will we be flying over?
We are flying over the South Pacific at the moment, heading towards South America.
That.
A view from the International Space Station Flight Control Room. Teams here looking over the procedures as they are about to start the spacewalk here shortly, switching to battery power. At this time, the International Space Station, 271 statute miles over the southern Pacific Ocean, just entering into an orbital sunrise. By the time the crew exits the International Space Station, they will be in the daylight.
Delta right at 1. Right now.
Copy.
A great view of the station's airlock. That thinner tube that's sort of at the center bottom of the screen is where the crew is now on the inside. The hatch just off to the upper right portion of that crew lock. Crew inside now, near vacuum, working through the steps to exit the hatch here shortly. That'll come after they switch to battery power and officially start today's spacewalk.
About 0.9 psi delta, 0.9.
Copy.
Airlock Houston on Space Ground 1. Handover in 20 seconds.
Copy.
That handover will be when the satellites switch over. Communications being relayed through tracking and data relay satellites. These are geosynchronous satellites, just about 23,000 miles away. Astronauts Andrew Morgan and Christina Cook ready to begin today's spacewalk today, going through the final steps of the preparation before the spacewalk begins when they switch to battery power. Again, their primary task today is switching out some of the newer lithium-ion batteries that were delivered recently by the H-2 transfer vehicle, the Japanese cargo vehicle, just about a month ago. That pallet with the new lithium-ion batteries situated right next to their work site will be switching out some of the older nickel-hydrogen batteries. Some of the work already done. As of 5 days ago, the first of the series of 5 spacewalks completed. They got a little bit ahead of schedule and got into some of what was originally today's procedures, at least the beginning portion of them, for the 2B channel. That's one of 8 channels, power channels on the outside of the International Space Station. The 2 spacewalkers completing that just 5 days ago. Now swapping positions, Andrew Morgan taking the lead spacewalking position today as EV1, Christina Cook as EV2.
0.6 on my DCM.
Getting some audio and video communications back as the satellites switch over.
Gauge on the hatch gauge. Alright, Jessica and Houston, I'm showing right at 0.5 psi alpha. Do you agree? We have a go to open hatch.
My numbers agree. Houston, do you concur?
Checking. We like your number. We're not seeing that telemetry yet on the ground, but your go.
Okay, copy. Go to open the hatch.
Andrew Morgan reporting some good numbers. It's Mark Van High, the Capcom on the ground. You can see they got the go to open that thermal cover that you just saw fling open just moments ago. Now, the official start of today's spacewalk will begin when they switch to battery power. These still some of the preliminary steps before they officially begin.
And for EV2, I have the expression SUP high.
And I did as well. SUP high message. You got the it was expected.
Copy. See sunshine.
We're in the hatch keep, and the thermal cover is already opened.
Okay, copy that, Drew. Looks like a beautiful day out there. Have a very productive and wonderful time on your spacewalk, and I will hand you over to Stephanie.
Great work today, Jessica.
Thanks, dude. You guys are awesome.
Right, you guys too. Good luck out there. We'll be waiting for you inside.
Thanks, Stephanie.
Thank you, Jessica. Drew, Christina, good morning. On your DCMs, take power to bat. Stagger your switch throws and expect a warning tone.
Copy and work.
Handing over from Jessica Meir to ground Ivy Stephanie Wilson. You'll be hearing her voice from here in Mission Control Houston throughout today's EVA.
EV1 display switch is functional.
EV2 functional.
Christina, on the UIA, take power EV1, EV2, 2 switches to off, OFF.
In work. Power EV1 and 2 is off, OFF.
Copy, check power EV1, EV2, 4 LEDs are off.
4 LEDs are off.
On your DCMs, disconnect your SCUs from your DCMs and stow them in the pouch.
Work.
And we have a good switch to battery power.
EV1 stowed in the pouch.
That occurring at 6:38 a.m. this morning, Central Time. The International Space Station just over an orbital sunrise, 267 statute miles over the South Pacific Ocean just west of the coast of Chile.
Copy that. Now install your DCM covers.
1 DCM cover installed.
2 DCM cover installed.
Copy. Christina, check deep press pump man ISO closed.
Press pump man ISO valve closed.
On your DCMs, take your temperature control valves to max hot.
In work. EV1 max hot.
EV2 max hot.
Copy. Take water to on.
Copy. EV1 water on.
EV2 water on.
Check DCM blank, bite off.
1 DCM blank bite off.
DCM blank bite off.
Copy. Take your temperature control valves as desired.
Copy.
Complete for EV2.
And EV1 I'm set.
Copy. Check suit P gauge between 4.2 and 4.4.
EV1 4.2.
EV2 4.4.
Copy 4.2 and 4.4. Visors as required for day.
Work. EV1 visor set.
EV2 visor set.
Copy. We have good suit parameter data, and we have taken care of the airlock VRIV. We show the hatch thermal cover open, and you can egress. And we're over Brazil.
Copy, I see it. Beautiful. Right. Now, then
Looking good.
2 spacewalkers getting great views of Earth as they pass right over South America, going through that checklist to get all the preparations before they actually exit the hatch. First spacewalker coming out now.
And then I'll pause right here in the hatch to do our tether work. And Stephanie, I'm in position. I have view of our tethers.
Copy. We're ready.
Okay, and I believe that I'm making my first connection, my yellow hook to the forward green rail. So I'll take a quick look, inspect them real quick. Okay, on the forward reel, there is no indicator showing. The load alleviating strap looks good. The hooks are locked. This green hook is locked, and the reel itself is unlocked.
Copy your checks for the forward external D-ring.
Okay. I put my yellow hook to that green reel, and it's declosed, slider lock, black on black.
We copy, Drew. Now inspect the load alleviating strap on the aft external D-ring.
That load alleviating strap on the aft D-ring. There's no indicator showing. The load alleviating strap looks to be in condition. Green hook is down to the aft D-ring, and it is still locked, and the seal itself is in unlock and also looks to be undamaged. Example.
We copy, Drew. That's
that I connect my green reel. My green hook back to my reel.
Yes, well, that's a good check for the aft external D-ring. So next, attach forward safety tether green hook to your red reel.
Andrew Morgan, you see positioned right outside of the Quest airlock hatch. He's the first spacewalker out today, checking some of the tether configurations, making sure they're all set before they actually make their way over to the work site on the very far port side of the International Space Station.
To my red reel, and I'm going to leave it in unlock.
Copy. Next, attach Christina's yellow hook to the safety tether reel on the aft external D-ring.
Copy. Christina's yellow hook is to green reel that is attached to aft ring, closed slider lock, black on black.
Copy, Drew. Next, attach the aft safety tether green hook to Christina's red reel.
Copy. Now, Christina, for this, I'll have you move a little bit closer to the hatch.
Copy. What's that?
Straight. Okay. Christina's green hook is attached to her red reel. Let me just make sure that we're good here.
Good reports of the tethers configuration. Make sure they're attached to the International Space Station safely. You can see the feet of Christina Cook poking out from the airlock.
For Christina, we give Christina the go to egress.
You'll be able to tell the two apart by the stripes on their suit. Andrew Morgan wearing the suit with red stripes. Cook with no stripes, plain white suit.
Okay, man, your go to release that waste tether and come on out. I'm on the forward side.
Copy. Go to that side. Okay, my right waist tether is released.
Okay.
I'm on the aft side.
Let me get a look at you for buddy checks.
Okay, and Stephanie, I am egress.
Copy, Christina.
Small ORU bag.
Copy that.
And man, I come a little bit toward me. I just want to.
Okay. I'm going to get this on my BRT.
Copy.
Both crew members outside the Quest airlock today with tool bags in tow. Before they head over to the work site, they have a good tether configuration. They have their tools attached to their sides. They'll do some buddy checks first, just making sure that their suit configuration and everything looks good before they make their way further away from the airlock to their work site on the far port truss.
Looks good. Yep, and I'm just going to make sure that that goes above your D-ring extender. There you go. We prefer it this way, I imagine.
Yep.
Okay.
Great. Thank you.
Okay, and Stephanie, I can start buddy checks on Christina. I see she has one good green WVS light, and I can see two handles down. But since you put the bag on, let me just see that left hip one more time. Okay, both handles are down, and I see three tabs up. My half is dry, and I've had a really good baseline look at my gloves, and I understand where we are at baseline. Over to you.
Okay, for your safety checks, I do have one green WVS light, and on your spacer handles, the man ISO valve is up, so I can use that hip towards me. I'll get that down.
On my left hip here, great.
Affirmative. Okay, the man ISO valve is down.
Copy.
And your HCM handle was down.
Copy.
Tabs. I see three tabs up. I see a good tether config. Both reels are in lock, and everything is in a good position.
Okay. If you agree, Stephanie, I think we can start the translation out, and Christina will grab the we'll cover.
And Christina, give us a baseline HAP check, please.
The HAP is dry.
Copy, dry HAP. There is a warning and a caution before translation. Remember the potential sharp edge on the airlock with 8 label. And also the caution for phase 1, avoid contact with deployed test cable, zenith, and NATA CETA rails. And you can begin translation with Drew leading.
Copy all. I'll go ahead and close the thermal cover.
Very good. Thank you, Christina.
Thermal cover is closed.
Copy closed. Thank you.
And the crew members going through their safe checks. Now everything confirmed. Tether configurations are set. Tools are in tow. They've closed the thermal cover, and they are on their way to their work site to begin today's spacewalk, even just a little bit ahead of schedule. The two spacewalkers have their spacewalking legs as of 5 days ago, both of them going out the hatch to start this series of battery upgrades. Now continuing for the second of 5 planned EVAs for the series of power upgrades to the station. Sad news today to report, though. As Andrew Morgan and Christina Cook begin their spacewalk, we have learned that, and Roscosmos has confirmed, that Alexei Leonov, the iconic Russian cosmonaut, passed away today in Star City, Russia at the age of 85 today, October 11th, 2019. Leonov became the first human to walk in space on March 18, 1965 during the Voskhod 2 mission, a 12-minute spacewalk that began the history of extravehicular activity. Leonov then commanded the Soyuz capsule in July 1975 for the Apollo-Soyuz test project along with fellow cosmonaut Valery Kubasov, and linked up with the Apollo command module commanded by Tom Stafford, along with astronauts Vance Brand and Deke Slayton, that gave birth to the international cooperation we see today aboard the International Space Station. Alexei Leonov, dead at the age of 85. A tribute to Leonov, as today is a spacewalk, the first spacewalker in history.
I am at the cedar rail.
Copy. Christina, you will translate to P1, mile marker 9180 under the FHRC to check the anchor hooks. And Drew, you'll translate out to P6 to place your green hook.
That.
A live view from the International Space Station Flight Control Room. The team's here overseeing the spacewalk today. You'll be hearing the voice of Stephanie Wilson up to the 2 crew members that are spacewalking today, Andrew Morgan and Christina Cook. At the far end, you can see Stephanie Wilson. She is the ground IV, the spacewalk communicator. While she is speaking to the 2 spacewalking astronauts, Mark Vande Hei, taking control of the inside. Of course, crew members still on the inside of the space station. He'll be the voice from mission control up to the crew members there. Flight Director T.J. Creamer leading the Orbit 2 teams today. Next to him, Judd Freeling, the 2 flight directors of these battery spacewalks, the 5 planned spacewalks this month. In the meantime, Morgan and Cook on their way to the work site, which is on the very far end of the port side of the International Space Station, right at the very end where the solar arrays are.
Copy, Drew.
In locked, or excuse me, in locked. They are black on black. They're locked. I know Christina's going to give them an eye, too.
And we copy.
They're doing what's called translating now. That's just moving from the Quest airlock over to that work site. Translation is just the physical movement from one place to the other.
Is in on lock, but it is not reeling in. I gave it a tug, and now it's reeling in. By tug, I just pulled it out lately to give it a restart for the reeling in.
And we copy. Thanks for the report.
Part of the movement over to the work site includes checking those tethers along the way. Again, that's a critical technology during a spacewalk to make sure they're attached to the International Space Station. Good reports, though, as they make their way over to the work site to begin today's battery EVA spacewalk.
That is yours. That's the vertical handrail, and 3650 is the horizontal handrail. That's Drew's.
Be in work. Yes, mine is on 3651. Close, spider lock, black on black. for Drew. His is
Getting some of the first views from the wireless video system aboard the crew members. This one, helmet camera number 11. You can see the translucent letters at the bottom right. This one, the helmet camera of Christina Cook.
Checks of the anchor hooks. You can continue translating to P6 to also place your green hook.
Spacewalkers making their way over now, familiar with the translation path. This is the path they would use. You can see the handrails they're grabbing to make their way. Spacewalking, more of a hand movement than actual walking using their feet, but making their way quickly over to the work site. Again, helmet camera number 11, the helmet camera of Christina Cook. And we see 18 pop up on the screen. That'll be Drew Morgan.
Prior to crossing the Sarge, check your gauntlets in place.
And I'm at the Sarge, and those gauntlets are down. Stop and start dropping now.
Copy.
and I am at the starboard seat cart.
Copy, Christina.
You can see Drew Morgan already making his way towards the work site. The work site on the very far end, that second set of solar arrays on the far right. Drew Morgan, you can see identified by the red stripes on his thighs. He'll be EV1 today. When his helmet camera is up and running, it'll be helmet camera number 18. You can see as he makes his way down the truss, the canted arm positioned just, I guess, below him from his vantage point at the end of the canted arm is the external pallet. This pallet contains the lithium-ion batteries, two of which have already been switched out and are currently on the station with associated adapter plates. That'll be for the 2B channel. On the far side, there's the 2B and the 4B channels. They've been working on the 2B and are scheduled to finish that today, installing the third of 3 on that channel. The remainder of the 6 batteries that are part of the 6 that are on the pallet will go on the 4B channel on the other side. From this position, you can see Andrew Morgan just below his feet. There's that external pallet with some of the batteries, some old, some new, based on the work from 5 days ago.
My left gauntlet before proceeding.
Copy, Christina.
I'm at 5312 for my green hook.
Drew, that is a good handrail. Your green hook location is 5312. And for both of you, there's one warning and one caution for P6. Remember the P6 sharp edge hazard, empty rail attach lug near the 2 Bravo IAA inboard radiator corner, and also on P6, avoid contact with deployed and stowed radiators.
Copy that. And for EV2, I am about to cross the Sarge. My gauntlets are down.
Copy, Christina.
My green hook is down.
Copy, Drew. Next.
12.
Copy. Green hook on 5312. Next is to place your adjustable Richman fair lead on handrail 5307.
And then I put my green hook on the more inboard stanchion this time. It'll be a little bit under the APFR, but I think it's just going to make it a lot easier to get it off. I don't think it'll be an issue.
Copy.
Copy.
APFR will be a term you'll hear a lot today. That is the portable foot restraint that they'll be using They'll be ingressing that foot restraint as part of the work today. That's actually putting their feet into a position once they get that APFR or portable foot restraint in the right position to access some of the batteries and perform some of the handoffs. Drew Morgan at the far end of the station, you can see Christina Cook coming right behind to meet up. The two of them will be working concurrently on some of these battery maneuvers coming up shortly.
Okay, I am at 5309. I believe this is my green hook location.
That's correct.
A great view of both spacewalkers out at the work site. Just below them, 260 miles is the Atlantic Ocean as they come up on the western coast of Spain.
Green hook is dropped on 5309.
Copy, Christina. Next, translate to the EP.
My Satelite is in place on 5307.
On the left, Christina Cook, the suit with no stripes, good tether configuration. She's going to make her way to the external pallet you see at the bottom right there with some of the batteries at the end of the station's robotic arm.
And while Christina is translating to the EP, and Drew, this will apply for you later, I have 2 warnings and 3 cautions to read for the EP.
Copy that.
Okay, copy. And do I have a go to go ahead and translate over? In position.
Yes, you do.
Yeah, I am on the EP. And I'm the first step.
Copy. Your step will be to stow the ORU bag on the EP handrails 7307 to 7306 to 7307 between batteries B and D. And the warnings and cautions, the 2 warnings, EP wheels are no touch for pinch points. EP grapple shafts and teeth are also no touch. For the 3 cautions, translate only on handrails. Do not impart loads into any ORU on the EP. No sudden movements on the EP. Maintain less than 0.45 feet per second translation speed. And wait until EP motion dampens out before imparting any loads.
Copy.
Ground IV here in Mission Control Houston, Stephanie Wilson reading off some of the restrictions as she begins to access the work site where she's at. That's the external pallet. This one was extracted from the H-2 transfer vehicle, that Japanese cargo vehicle. Right now she's in a position that will begin some of today's work. On the external pallet, each of those slots has an identifier, all marked by letters. In between B and D will be some of the beginning work. In slot B is the adapter plate, where that currently resides. That'll be part of the first bulk of the work, moving that adapter plate over to the station, and then moving an old nickel hydrogen battery over to that slot B on the external pallet. Right now, though, the two spacewalkers just configuring those work sites before they actually begin that handoff. Christina Cook just installing a bag, just hooking it to the side of the external pallet.
The ORU bag is out, and I'm going to the second point down.
Copy, Christina.
Christina Cook still configuring that bag that will be positioned at the work site for the first of their series of battery swaps.
7307 and 7306 AET.
Copy. Nice work, Christina. Next, configure the PGT with a hex driver.
PGT is another term you'll hear a lot. That's the pistol grip tool. That'll be one of the primary tools they use for the battery swaps today. Basically a space drill, just configuring it with the right tips to make sure they can actually work with the batteries today. In the meantime, Andrew Morgan on the right there, you'll see his helmet camera 18. His job will be to work with the portable foot restraint first, getting that into position.
Seconds from a 20-second handover.
Copy.
Spacewalk 57 underway, just over 30 minutes into today's spacewalk. Ground IV Stephanie Wilson confirming that handover as expected. Switching over satellites, we'll be regaining video and audio communication here shortly. This is a very short handover. Meanwhile, the International Space Station, 260 statute miles right over Poland.
We're back with them.
Okay.
And Stephanie, do we have you back?
We have you back. And Drew, we are checking for your quiescent state whether it can change.
And for me, Stephanie, I have the 9-inch hex installed on the PGT.
Regaining audio communications from the spacewalkers, still getting their work sites prepared before they begin the swaps. In the meantime, we'll answer an Ask NASA question. Why is a spacewalk required to install the new batteries? Couldn't we just do it robotically? Well, that just has to do with the actual configurations of the batteries themselves. Some of the tools on the dexterous manipulator are very helpful for maneuvering some things, including some of the power systems. Just recently this year, back in May, we used robotic swap for the main bus switching unit, which is another electronics component as part of this power system, but the batteries need a little bit of that human touch with special spacewalking tools needed for the bolting and attaching some wires to make that a possibility. Now regaining some video communications, we still see Christina Cook at the external pallet there, making her way back to the station.
Fox, Golf 3 confirmed.
Copy. Those are good settings. Double check the wire tie ends are tucked under the footplate.
They are.
Copy. give me a glove, hap, and gauntlet check.
Any change on the glove? Hap is dry. Gauntlets are down.
Good checks by the crew. Crew nearly ready in the preparation portion of their spacewalking procedures today. The next series of steps will be to actually swap the batteries. There's several steps. Again, there's a lot of swapping, a lot of batteries to work. So the first will be actually switching the positions of an adapter plate that currently resides on the external pallet and taking one of those old batteries and putting it on the external pallet. Here's a graphic that we see as the station and the pallet are configured now. You can see the legend on the bottom right. You can see two of the lithium-ion batteries have already been put into position from last spacewalk. Now we're just going to be doing a series of swaps to get that last lithium-ion battery in place. The first maneuver will be taking an adapter plate that's currently on the B slot of the external pallet and putting it on slot number 4 of the station, and then doing a handoff with the old battery, taking it from the number 4 position on the station and putting it over on the B slot of the external pallet.
The 9 inches on the PGT, so I checks with a good pull test.
Copy, Drew. Christina, we wonder if you would have a good view of Drew's APFR, and if you could check his APFR settings in WIF 22.
Sure. Yep, that's in work. Hey, Drew, look towards your APFR real quick. Is that in the distance, the moon?
Oh, yeah.
Cool. Okay, APFR settings are 12, Quebec, Quebec, Hotel, 12.
Copy. Those are good settings. Double check the wire tie ends are tucked under the boot plate.
They are.
Copy. Thank you.
Now you'll hear APFR be said quite a bit, as well as PGT. These would be some of the main tools that I use, especially in the beginning of today's spacewalk. That APFR is a foot restraint that Andrew Morgan will actually enter as part of the first part of these procedures. They'll use that PGT, that pistol grip tool, basically a space drill, and they'll use that to work with some of the bolts to begin some of the maneuvers of the adapter plates and batteries.
Battery 4? Yep, copy. And Drew, I'm positioned just inboard of you.
Okay.
TSCS, and I'm happy to help with any config you're doing.
Okay.
Or just second me.
I think we're just about configured. So right now I have the adjustable and the Red series, the PGT tether point, Stephanie, and they're both back to the bag.
Copy, Drew. Then give me a glove, hap, and gauntlet check, and that will complete the setup.
Okay, the half is dry, and change from baseline only gloves.
And double check gauntlets down.
Gauntlets down on the left and the right.
Copy, thank you. Good checks. There is one caution here on the IEA. Once torque is broken on an H-bolt, do not impart loads into the corresponding microsquare.
Copy that.
And I copy too.
Thank you. Drew, check gap spanner clear of battery 4.
Copy, it is. And we're just gonna, I'm gonna put this down on this tether point for now, just to keep it from flailing around.
Okay. Stephanie, we're talking about the temp stow, the PGC. If you know where that's going, we can go ahead and get it to its final destination.
Copy, Christina. You can stow that to the tether point on the battery in slot 3.
Copy, and we're just going to put it to the job. And that's complete.
Copy.
So the worksite preparation is complete. That knocks off the egress where they actually exit the Quest airlock and prepare their worksite.
When you're happy with the bag.
So they have their tools configured and positioned, including the portable foot restraint and the pistol grip tool. With that worksite preparation completed, they're off to the first task, which includes taking an old nickel hydrogen battery and placing it on the pallet, and taking an adapter plate and putting it on the station. You'll hear IEA quite a bit as well. That is the work site where the batteries reside on the station. The EP will be the external pallet where the new batteries are positioned at the end of the station's robotic arm at the bottom right of this view on the screen. Again, the first steps underway after the work site is prepared. First step would be to take off the old battery and put on the new adapter plate.
No more in on the heel?
Hang on a second.
Okay.
The issue is joint arm on that.
Good call. It is in. It is in.
Okay. I'm looking at the right one. Yep. Serial number 0099.
Copy 0099. That's expected. Check ingress aid stowed and tethers clear.
Aid is stowed.
Copy. Attach a RET to the H1 scoop, locking it out with slack. And Christina, you can, and I see that. Drew, you have the PGT. Just let me know when you're ready for settings.
Copy. So my RET is on H1, and lock it out here.
I'll go ahead and get the PGT on for you.
Yeah, if it's, we can get it calibrated while I set the tension on this RET.
Okay.
Andrew Morgan working on putting his RET, his tether, to a scoop. This is a handling aid that attaches to a battery, makes it a little bit easier to work with. While Christina Cook, you can see from her helmet camera configuring that space drill for the right settings to begin this series of battery swaps here.
Encounter 2 is set.
Right now, the two spacewalkers beginning the series of swaps by, they're going to be taking off an old nickel hydrogen battery and working on some of the bolts that are securing it in place, releasing those. They'll attach it to themselves and make their way over to the external pallet to begin the swap, where the adapter plate currently resides and will take the place of where the nickel hydrogen battery currently is.
You'll confirm tape line flush to the H1 scoop.
Copy.
Tape line flush.
Okay.
Copy. Release.
Line flush, and then Christina, I think it's low in my envelope here.
Say again?
I'm low in my envelope here. I think if you think that looks like we're good and vertical.
Now it is. Yep.
Okay. Starting turns.
Release H1, 8 turns.
Copy.
Drew Morgan currently in the foot restraint, in his hands the pistol grip tool. You're seeing the view from the helmet camera of Christina Cook, who's handing off the tools to him as he's in the proper work site with the right angle to get into, to access that bolt. Again, two bolts holding the nickel-hydrogen batteries in. They're setting the space drill now to work with that interface.
Motor. Alpha 7 or 2 set again. Nope.
Copy, good settings.
Tape line flush.
Tape line flush.
Stand by, let me get it centered.
Copy, tape line flush.
Starting turns.
Release about 8 turns.
Release.
I agree. Yep.
It released at 5.
And let's say we are indicator unlock on H1.
Copy, 5 turns. Status indicator unlocked for H1. Same settings for H2, Alpha 7, counterclockwise 2.
How's your work at
Drew Morgan heading over to that next bolt after working with H1. Those bolts indicated by H1 and H2.
Help me with making sure we're vertical.
Okay, I can talk to you. Let's see, tape line flush. To bring it vertical, bring the top of the PGT towards the speed. There we go, that's vertical.
Tape line flush.
Copy.
Alpha 7 counterclockwise 2.
Good
A
config.
little more towards your feet. There you go.
Release H2 about 19 turns.
Copy, 19 turns. Starting turns.
Tracking.
Andrew Morgan, Christina Cook, working that PGT, that pistol grip tool you can see off to the left, turning. They'll do 19 turns here. The International Space Station itself, 256 statute miles over southwestern China, entering into an orbital nighttime. We'll start seeing the views from the helmet cameras of our spacewalking astronauts get a little bit darker. They'll switch on their lights that are on the helmets of their extravehicular mobility units, their spacesuits, that'll illuminate their work site as they continue to work with these bolts and work through their procedures.
Copy. 18 turns, status indicator unlocked for H2. Christina can stow the PGT.
PGT.
Got it.
To unlock the RET.
It's unlocked.
Copy. Work together to remove the battery. Once Christina is in a good position for the handoff, she will receive the H2 scoop.
We'll do the H2.
And I'm working on my PGT just around the gap spinner a bit.
Let's see. You are over, looks like you are almost clear.
Sunset approaching in 2 minutes.
Okay.
From the helmet camera of Christina Cook, you're getting good views of the scoops that they're referring to. These are handling aids, just basically a metal rod you can see sticking out from the bolt that's securing the battery in place to the station's work site, the integrated electronics assembly.
I also have had a couple of moments today that have already been, if it can, it will, little things been good.
What I'll do is,
lot of help.
Orbital nighttime becoming apparent from the helmet camera of Christina Cook, number 11, at the bottom right corner of the screen. Astronauts needing to switch to the lights that are mounted on their helmets to illuminate the work site as they continue these battery swaps.
Good with that pathway then.
Space Station 255 statute miles in an orbital nighttime over the northern border of Thailand.
All right, let's tether and stay consistent.
The resistance on the PGT swing arm good for you?
It is.
Yeah, okay.
Yep, it sure is. Okay. So let me go ahead and get into a position. So we talked about me being high here. This one. Sure.
Yep, I agree.
All right.
Pretty good handhold there.
Think PSCS handhold or and higher?
Oh, I'm going to... Big thing is I'll just need enough room to back away here and hand H2 off to. So I think that'll be a good distance. And I think if you turn more or less parallel to me, and I'm assuming that I'll be handing H2 to your left hand.
All right, so this is my position if I'm all the way on the radiator side. I think that's going to be far to get down to you when you're on the non-radiator side. The K turn.
Let's take a look here. Even if I have to come a little bit closer, I think we'll be okay. I think H2 to your left hand is our bet right here, which means I think if you put that left hand, if you kind of barn door toward me, left hand up in the air, yep, and then H2 come around, it'll go fins up.
Okay, I see that.
Does that look?
Okay, I have H2 and standby 1. Let me get a better grip. Okay, I have the battery.
Okay, well, we should have good length with the red here. You have the battery, remember I'm staying right to it while I get out.
Okay.
There we go. I have the battery, and because of our proximity, I'm going to be a little more bumpy with it.
And I see good rep positioning for you. It's not drawn out at all.
Okay. I'm going to come down the HFR.
Okay, I'm ready for that. Let's just walk it down. I've got the battery.
From the helmet camera of Christina Cook, you can see in her left hand in the scoop is the lithium-ion battery, holding it in place as Drew Morgan gets situated. The two of them will be maneuvering the battery over to its new home on the external pallet. Of course, taking up the slot where the nickel-hydrogen battery is to reside is an adapter plate that's to be put on the station. So at the external pallet work site, they'll make a swap, do a handoff with the old nickel-hydrogen battery and an adapter plate.
Need to recheck that roll. I'll need to recheck roll here when I come back.
Okay, copy.
Okay, if you think I still have a little bit of length, I can get a hand right here.
That's where it's going because I see a straight line between, yep, and we still have space. I only see it reeled out about 2 to 3 feet.
Okay. right, we'll just need to get it up and maneuver it a little bit here.
Okay, let me know when you have it.
If you could help me just rotate so we're more fins up. Okay, I have the battery.
You have the battery. All right, now if you keep it there, I will translate down the inboard edge of the IEA.
Perfect. No, this worked out well because it'll leave you just enough space.
Okay.
These verbal cues are key to the teamwork needed as part of this spacewalk. Verbal confirmation of who has the battery, obviously attached by tethers, but to have that physical grip on the battery is important.
My safety tether, I see it free, not caught in anything on those ORUs. I'm a P6 spacer.
Worked out well, I think.
Yep.
Because we're right back where we're very familiar with.
That's correct. I agree.
Go further by at least a foot and a half or so.
Okay.
I think that might be
That's about it?
Right.
All right. Yeah, I have the battery.
You have the battery.
And I am all the way in.
All the way
Inboard.
Okay, copy. Get to this. Away from structure just a bit.
Right?
No, I'm almost there.
Okay.
If I could come one more, if you can maintain control,
Yep.
I'll come in one more handrail.
Hey, and I do have control of the battery.
Okay.
And just check the rep position with your local. Make sure that I see it around it.
Right, yeah. That while we get on
I
ourselves.
think it's okay, but yeah.
I think that's as close as I'd probably be able to legitimately get, and I have the battery.
Okay, you have the battery.
Now again, Christina Cook and Andrew Morgan working on that nickel hydrogen battery you see at the bottom, coming from slot number 4 on what's called the IEA. This is the work site where they're at on the station, where the batteries actually store the power for the station. Right now they have that nickel hydrogen battery in tow. Their next step would be to move over to the external pallet. And from there, they'll make a swap with the adapter plate, which currently resides in slot B of that external pallet. They'll unbolt the adapter plate and make a swap, and then nickel hydrogen battery will be stowed on the external pallet adapter plate over to slot number 4 on this station's work site.
How far you are from the entry floor. You're on the next handoff.
Okay, copy.
You have the battery.
Copy, you have the battery.
Again, those verbal cues critical to the maneuvers here today to get that nickel hydrogen battery in place. They have to alternate between holding the battery and switching up their tether configurations, which you can see from the helmet camera of Christina Cook working on right now. The next step, once they get their tethers configured, will be to move over to the external pallet. That's where the final destination of the battery they're working with now will reside.
The battery.
That's the battery. Hey, should be able to do the handoff. People, I have the battery.
You have the battery? And
You can see from this view a little bit difficult to tell from the nighttime, but Christina Cook and Andrew Morgan making their way close to the external pallet. You can see off to the bottom right of the screen.
Verify APFR roll and yaw, Golf 3.
I have golf and 3.
Copy that. SSRMS brakes are on. You have a go to ingress.
Again, that's a portable foot restraint, a key component to getting the astronauts in a good position to work with the tools and the adapter plates and batteries today. Christina Cook working now to ingress that portable foot restraint, meaning getting her feet into a position. That foot restraint will put her into a nice configuration where she'll be able to easily use the pistol grip tool, that's that space drill, and work on some of the bolts for the adapter plate, which currently resides in the position where the nickel hydrogen battery is to eventually be placed. This is the same one that they have in tow. They'll be making that swap between the adapter plate and the nickel hydrogen battery as part of these next procedures.
bit more.
Okay.
Right toe is in the toe loop. On the boot plate and right heel.
You can see off to the left there, that's Christina Cook working with that long structure. That's the foot restraint that she'll actually enter into. You can see it's off from the truss structure quite a bit, and that puts her in a good position to actually work on the external pallet. The next steps for her will be to use the pistol grip tool to unbolt the adapter plate that currently resides on the external pallet. In the meantime, Drew Morgan holding that nickel hydrogen battery where once the external pallet is removed, or the adapter plate is removed from the external pallet, that's where the nickel hydrogen battery will reside.
On the right.
On the right.
So it looks like it's about the correct depth.
A good angle to show Christina Cook. You can see there's a handling aid right where her hands are that helps her to actually enter or ingress that portable foot restraint.
All right. 8. Job.
Concur. Nice job, Christina.
Stephanie, I am ingressed and ready for steps. My ingress aid is showed.
And check tethers clear.
Your release.
Yes, the tethers are clear, and I believe this is going to my BRT, so let me go ahead and deploy that.
It's affirmative.
Do you agree?
We do agree. Perform a RET swap and attach your BRT RET to the battery tether point. And you'll receive H2. The H2 scoop will be placed on your BRT.
Okay, copy and work.
Good confirmation from Christina Cook. She has entered into the portable foot restraint. Just has to make sure her tethers are out of the way, that she has good access to the tools that she'll be using. The next step to stow a scoop, that is a handling aid that she'll use to actually maneuver some of the components here today.
You may not be able to do this in one RET swap.
Yeah, I think that I'm going to need to have you go to the scoop there.
Okay, I'll go to the scoop, and then you can get yours, and then I can get mine off. Okay, stand by when you fill out the battery.
I have the battery.
Okay. Okay, I am ready to the battery, and I have the battery.
Okay, you have the battery.
Yep.
Stay right about there, and I'll be able to get this off.
Okay. Let's you a little bit.
Yeah, my red is off.
Okay, copy. I have the battery.
You have the battery.
Christina Cook in the portable foot restraint, battery in her hand.
Stephanie, any issue with the RET staying on H2? I think maybe the reasoning was just to keep the scoop clear for BRTing. Given the handoff positions, it was easier to do the RET swap this way. I am able to get the H2 scoop on my BRT with the RET on this scoop as well.
Christina, we copy, and you are correct in your assessment, and we're happy with the config.
Copy.
Now, I have 4 cautions. Crew must not simultaneously impart loads into the EP. When SSRMS brakes are off, free float crew member on the EP must remain quiescent. When braking torque on the EP, apply less than 55 pounds force. And the last one, do not exceed 20 pounds force during ORU soft dock, engage, disengage with the EP.
Copy all.
Copy all.
With that, Drew, translate onto the EP, retrieve the ratchet wrench with the hex driver. Christina will be using that to brake torque.
Okay, so Stephanie, at this point, I think I'm going to take a little bit of the GPA in because I'll be coming off of the adapter plate and I'm going to need a little better reach. If Luca is available, you can bring that. I'll give him some commands to speed it up.
And through Christina, on 1, I am at the station and I'm ready for any GCA request.
Houston's ready as well.
Okay, copy, Luca. Good to talk to you again. All right, Luca, let's go towards Christina's feet. Let's start GCA. Toward Christina's feet, 25 centimeters.
Okay, coming up with the brakes off.
Luca Parmitano on the inside of the International Space Station. He's at the controls of the station's robotic arm. At the end of the robotic arm, that's that external pallet, which Ground IV Stephanie Wilson just read a few cautions. It'll be up to Luca Parmitano to move it very close, slowly, but incrementally closer to the crewmates to make sure they have a good reach of their work interface.
Starting motion.
Robotic arm is in motion.
Copy, see motion. Motion.
And to go. Centimeters.
Okay, so it's a good spot there, Luca. We'll end GCA, and I'll ask Christina if there's anything else that she would like.
Okay, and for my GCA, I'm going to need body left about 15 centimeters.
15 centimeters, body left, starting motion.
Aggression.
Robotic arm in motion. Luca Parmitano making incremental adjustments in favor of the crew's positions.
We'll call that GCA complete.
GCA complete.
Okay.
On.
I understand, I think we heard brakes are on, Luca.
It's affirmative, brakes on.
Copy. Just like now.
Drew, with that configuration, you can translate onto the EP, 30 seconds to a 20-second handover.
Luca Parmitano from the inside of the space station, moving the robotic arm with the external pallet closer to the working spacewalkers today.
Be a good help right here.
Yep, I think so, and the bunch with the system shut for 9 inches.
Now in a short handover period, you're looking at the International Space Station Flight Control Room today. Leading the teams is Flight Director T.J. Creamer. As a part of the Orbit 2 team, the voice you're hearing from the ground here is Stephanie Wilson at the far end of the table there. She is communicating with the two spacewalkers. Mark Van de Heij communicating with the astronauts inside the station, Judd Freeling, also Flight Director today at the closest end of the screen.
Like on all the others.
And your tether point is down here. You probably see it. Not up high like the last one.
Getting some audio back from the spacewalking crew members. Again, Luca Parmitano moving the external pallet into position. The next step would be for Drew Morgan to go to the work site on the external pallet. From there, he's going to go to that tool bag that Christina Cook attached to the external pallet on her way over to the worksite as part of the worksite preparations. In there, he's got a couple tools that he'll hand off to Christina Cook, who's currently in the portable foot restraint, in a nice position to work with the adapter plate and the battery that she currently has attached to her side. Again, the adapter plate currently resides on the external pallet. She'll need to unbolt that to make the swap because the nickel hydrogen battery will go in the same place where the adapter plate currently resides.
Christina, Drew, we're back with you. However, we have a couple minutes of blockage, so we may experience some dropouts.
Copy that. So to catch you up, I have the ratchet wrench with the 9-inch hex in my hand and ready for steps.
Copy. To brake torque on H1, confirm one line flush.
Okay. And I'm in a good position for H2, or I can hand this to Drew for H1. So let me see if I get H1. Drew, I think I'll either need some more GCA or a hand with this. Let's see if I can get H2 from my position.
Christina, we prefer braking torque on H1 first, and either of you can brake torque on either of these bolts. Whoever's in a good position can do it.
Copy.
Ground IV, Stephanie Wilson here, working with the teams. There's a lot of support here in Mission Control Houston, led by Flight Director T.J. Creamer. Keith Johnson as the extravehicular activity flight control officer here in Mission Control Houston in the front room.
One line flush on H1.
What you're hearing now, as we are losing communication, or as we lost video communication with the station temporarily, Stephanie Wilson, Ground IV here in Mission Control Houston, you're hearing Christina Cook at the other end, confirming that she's working with the pistol grip tool. There's two bolts that are holding that adapter plate into place. She's driving one of the bolts there. There's another one she has to work with afterwards.
I'll get it on the, I can get it in the...
Okay, yeah, if you can get it in, if you can get it flush, and then I can put the...
Bring it flush.
Okay. And is it, if you're able to hand on the palm wheel, or give it a turn?
All right. Fork broken on it.
This is the helmet camera from Christina Cook. You can see the tool she's using to break the torque. This will help to work with some of the bolts as she hands off, depending on who has the better position, with the pistol grip tool, that space drill, that'll actually be used to drive those bolts and pull off the adapter plate.
You were still in this period of RADICOM. We copied torque broken on H1, I believe, and what percentage of a turn of 1 did you receive?
And I now have the ratchet wrench on H2, unlined flush, ready to break torque.
The good config for H2.
And you cut out, Stephanie? Again.
Good config for H2.
All right. Order turn. Pass this down to you.
Okay. I've got it.
So again, two bolts holding that adapter plate into place. Christina Cook has a good position to break that torque of the two bolts. Good confirmation from Stephanie Wilson here on the ground. Now, Drew Morgan working with Christina Cook, handing her the tools she needs as she's in the right position. She'll configure the pistol grip tool for the right configuration to work with each of those bolts and get the adapter plate off of its current position on the external pallet.
We're still in this period of radicalm. I'm not sure we're copying each other, but I wanted to confirm you had H2 torque broken with a quarter turn.
That's affirmative. Good read.
Copy. Next is the PGT with the hex driver. I have settings when you're ready.
Okay, ready for settings.
And prior to that, we will take Drew's BRT rets, the non-locking end, and attach it to the adapter plate handrail tether point, locking it out with slack.
We have the BRT ret in place, and I'm putting in slack now.
Copy. PGT settings alpha 7, counterclockwise 2.
Copy. That is set. Alpha 7, counterclockwise 2 set.
It's a good readback. Confirm one line flush on H1.
Work.
Christina Cook working to drive the first of the two bolts holding the adapter plate into place as the International Space Station flies 271 statute miles over the southern Pacific Ocean, now entering into an orbital sunrise.
About 8 turns.
And it's released with 5 turns.
Copy 5 turns on H1. Same settings for H2, alpha 7, counterclockwise 2.
Alpha 7, counterclockwise 2 is set.
10 seconds to a 20-second handover. Confirm one line flush.
Line flush.
One?
No, the other one.
The one?
It's up towards me, so I'll have to wait. I'm done.
One is also...
Okay, yeah, get that one unlocked. Should be the other way, right? If you want to push it into the thin part.
Christina, I copied one line flush on H2. If you're ready, release H2 about 19 turns.
Okay, that's the work.
I see it jacking nicely.
Again, as we're handing over satellites, losing some video communications temporarily with the spacewalking astronauts, crew teams here in Mission Control working with the two spacewalking astronauts, still driving those bolts to get that adapter place off of the external pallet.
Before I pull this tool out, I just want to verify that you are ready, considering last time it did remove itself from stop job.
Yeah, so if you're fully released, I'll take the slack out of the ret.
And we copy 16 to 17 turns on H2. Copy G unlocking the ret, and Christina, take the PGT power switch to off.
Copy. In work.
And my BRT is ready to receive.
Make sure this is off. Yep, it's off. Okay, so the AP is out of soft lock as we expected. PGT is coming off.
Looks like the adapter plate is coming off now. The nickel hydrogen battery is currently attached to Christina Cook. She's going to make the handoff to Drew Morgan, who's got his BRT, his body restraint tether. You can see the clamp there. They're going to make a handoff, and he'll put it into his position to make sure it's secured to himself.
It's in position on the BRT. Back straight out just a little bit. And okay, if you hold it right there, I'll just grab it. Okay, paddles are out.
Copy.
Okay, and if you would maintain control there while I tighten just a little bit. Okay, and I'm going to put it just slightly this direction.
Good.
Okay. And I'm going to start to rotate away from you. If you could just follow me a little bit.
I will send it in your direction. Follow your motion.
Christina Cook getting a reflection of herself off the external pallet as she makes the handoff of the adapter plate secured to Drew Morgan at this time. Making the handoff, she's going to give him the adapter plate, and she currently has in her possession the nickel hydrogen battery that will be placed right in the external pallet that she's looking at right now.
Okay, keep sending her around.
All right, and it is out of my reach now, so you have it.
Okay.
It's in the slot and clear.
Okay.
Go ahead and move towards structure. Yeah, there you go. All right, so at this point, Drew, if you could bias yourself facing outboard. Right now, the AP is, the bottom part of it is between the two batteries on the EP. So get it kind of tucked in closer to you or to structure. Yep, now it's deconflicted, so it's away from structure and away from the EP.
Okay, I think I'm in a good position to translate with it. Thanks for the help.
Stop.
Drew Morgan already on his way away from the external pallet back onto the station. He has the adapter plate in tow. Right where they pulled the nickel hydrogen battery, which you can see currently attached to Christina Cook, positioned in the portable foot restraint, right on her side, ready to pull right in front of her and attach to the external pallet.
To the IEA, check your ingress aid stowed, retrieve the battery from your BRT with H2 in your left hand, soft